now. So before we start, one thing I wanted to mention, and I said this on the WhatsApp group as well. The classes will continue as they are now because I got all the survey results back and most students wanted it to not change, which is okay. Honestly, I think that might actually end up being better because you have the introduction by Tom and then you have his examples, which are obviously important. And then all the practice stuff, you have a chance to get answers, full solutions to those as well, along with some video stuff. So it's all good. I have no problem with it. Hi, everybody. Abdullah, Hassan, Tarek, everybody. Can't keep an eye on the participant list the whole time. It'll drive me crazy. So the last thing we did yesterday, we're working our way through functions, obviously. What we covered yesterday was graphs, domain and range, and then piecewise functions. The last thing we did was piecewise, which is 2 or more functions kind of put together. And we'll jump right back to that. So piecewise functions, let's see. The last one we did, I didn't do the full thing because piecewise isn't a huge part of this course. I asked you to try to get a few of these values, and these are the values that you should have gotten if you tried the question. If you didn't try the question, well, you didn't try the question. But for those of you that are working at it, that's the answers that you should have gotten. I drew the graph here just in case you're curious. So what we'll see here is that the function, when x is -4, should give this number, which is 4.5. So it does. So for those of you that have been paying attention, that should make sense. The other values should make sense as well. So for example, if we were asked about when x equals 2, well, we would look for 2 and we look at this graph, it should give us something around here, which is indeed 1.5. And so that's how this works. But I'm not gonna bang you over the head with this stuff. Piecewise functions are only a little tiny part of this course. And so I don't want to focus too much of my time there. The rest of this stuff, you'll have the full solutions. It's just for practice. You can do practice at home, okay? Or practice on your own, I should say. The next topic, or the first topic that we're going to start today, that again, I'll say it every time, you should already know because you should be watching the videos beforehand, is composite functions. And what composite means is 2 functions and you have one function put inside the other function. So you might have f of x, for example. I'll just do a little quick example on the side here. Let's just say we had the function f of x equals x squared. But then the function g of x, these are standard f and g. We usually use those letters. It's just normal, is x plus 1. Those are 2 different functions, but there's nothing stopping us from taking an entire function and putting it in for x into the other function. So for example, let's take the function g of x and stick it into f of x, or what I should say, stick it in for x, substitute it in for x whenever you see it. What this is called f of g. So the function f, when the function g is put inside of it, let me change the color. So for every x, we actually replace the entire function. Well, it used to be x squared. Now it's going to be x plus 1 squared. Let me move this down so it's not in the way of that g. You'll see that I've just put x plus 1 in for x. And now I have a new function. If you want to, you can expand this. It doesn't usually help, but if you wanted to open the brackets, you can. It doesn't change the function though, it just changes the way it looks. Okay, and that's composite functions in a nutshell. That's one function put into the other function, and we make a new function out of it. It's kind of like those Russian dolls. You know those dolls where you take one open, and there's one inside of it. You take another one out, and there's another one inside. If you have any idea what I'm talking about. It's like those. You put one function inside the other function, see what happens. All right, so before I actually go into anything, can I make sure that you're all alive out there? Seems quiet today. Are you all just really tired?
Sir, how did you do it this way, like x plus 1 and their own bracket and then square?
Well, what I did is, you see where the x is in the first function, right? This pink
Yes,
x.
yes.
I'm taking this other function g of x, which is x plus 1, and I'm putting it inside for x. So it used to be.
Oh, so you're putting g inside of x, not the
So
opposite.
instead of it being a number, instead of, for example, me having something like, you know, if I put 5 in for x, I get 5 squared. It actually turns into the entire function squared. Instead of numbers, we're putting in functions.
Yes, yes.
You see what I'm saying? Okay. So again, the examples were already done, but I want to make sure that we have full notes here. So composite functions is just putting one function, one or more functions, but putting one function inside another function. Instead of getting numbers, we're getting new functions for x. You know, we're replacing x with a function instead of a number. The other thing I wanted to mention is that we have all this stuff here. We've already talked about f of x, function of x, function of an x value. Now we have f of g, which is function of g, or function of another function. We just call it sometimes f of g because f is a function, g is inside. That's the big idea. If it's written the other way, which of course we can put g in f, or we can put f in g, we can call this g of f, or function of f. But let me just go ahead and show you the big idea. First of all, x is replaced with a function and not a constant value. That's the big idea. Let's go ahead and show you what I mean. So in 2 here, we've got 2 functions. I'll make them, you know, I'll make one blue and I'll make one purple or whatever. If our first function is 1 over x and our second function is 3x minus 6, find f of g. So you'll notice I put g inside f. Now, of course, look, f has brackets. You can put whatever you want in there. You can put a 0 or a 1 or a 10 or anything. You can also put functions in. It's just like a box. And we're choosing to put the entire function g inside. So this is what it looks like. We will have f of 3x minus 6. F, when x is actually 3x minus 6, the entire function. So every time we see x in the f function, we put in the g function. All right, so replace x. 1 over, I'm looking at this. It used to be 1 over x, now it's 1 over whatever g is. 3x minus 6. And there's nothing else to do. That's the entire answer. So that's honestly all there is to it for composite functions. There's kind of obviously more cases where things happen, or like it happens in a slightly different way. But really all we're doing, we replace all x, or all x's, with g of x. Just like we would normally replace an x with a number. Okay, are we all right with that?
Yes, sir.
Okay. To me, it's very clear because I find this topic very easy, but there's been many times that I've thought things were easy and then students are like, sir, I don't even have a clue what you're talking about. I lost you 3 days ago. I don't know what you're talking about today. But one thing you'll find with this course, you might already have noticed this, many of the topics don't relate to each other. So for whatever reason, you could learn something one day and the next day, and then the third day might not even use what you learned before. It's just the way it is. This course is just like a giant buffet of different ideas. So that's, for some students, that's good. For some students, that's bad. The next math course builds on itself from the start to the very end. So it's a totally different type of thing. Anyway, I'm getting off track. Try to do the second one yourself, okay? What I want you to do, you need to get g of f. And so you need to put f inside. Every time you see x, you need to replace it with 1 over x. So take 1 minute and try to write that out. You know, you can use the annotation if you want and write right on the screen, or you can write it in the chat. But I want you to try, okay? If no one tries, I'll pick someone from the chat to give me their answer. Okay, take 1 minute. Or 30 seconds. Okay, so Hisham has said that he thinks it's 3 over x minus 6. Anyone else have something they're willing to put forward? Okay, so I've got 3 answers, 3 over x minus 6. I also think that it's 3 over x minus 6. Now, this isn't a tricky question, but I wanted to make sure that you know the concept. So what I'm going to do, I'm going to write out, I could even write out the full g of x and say, hey, I've got an x there. I need to replace that. I need to replace it with whatever f is. So I should actually delete that and say that's 1 over x. I usually use brackets. So that's 1 over x minus 6. And I'm really glad you simplified it because it's kind of ugly the way it is right now. 3 over x minus 6. That would be our final answer. So let me just box them up here. Perfect. So C is asking us, and if anyone else tried that and you got the same thing, good job. For C, it's asking evaluate f of g for x equals 3. So we already solved for f of g. We have it up here, yeah? We already solved for that, so evaluate that when x is 3. Well, that's easy enough. We just take our function. So in this case, let me write out the full thing the first time. F of g of 3 is 1 over 3 minus 6. Okay, so be careful. I don't mean to put in too much highlighting here, but I'm trying to make connections. This function, I'll probably delete this highlight, but this function that I'm using is this one, because again, that is f of g. So be careful that you aren't getting lost here. It's easy to get lost, but the math itself is pretty easy. So that's 1 over 9 minus 6, or in other words, it's also 1 over 3, which I'm seeing in the chat. Some of you already got. So 1 over 3. Excellent. The next question, I'll write the beginning. Try to give me the final answer, okay? So g of f when x is 12. What about that? 1 over 3. Wait, 1 over 3 is the previous question, sorry. So let me see. I think I got something a little crazier. I managed to get negative 23 over 4. Because I'm using a different function this time. I'm going to use this function, and I'm going to replace the x with 12. So I should have 3 over 12 minus 6. And that's 1 over 4 minus 6. Or in other words, I think it's negative 23 over 4. And is that the decimal that it gives, 5.75? Excellent. It's no problem. You can give me the fraction or the decimal. Usually fraction is actually nicer because it's called an exact. There's no question as to whether it was rounded or not. It just is a fraction. But I'll accept both. I'm not too picky about that as long as you know the steps. So that is essentially composite functions. We put a function into another one. I want to mention that in Tom's video, he did mention there is kind of a shortcut for doing these last 2 questions. And that's because you can put 3, let me show you, let me just show you. Let's see here. We have f of x is 1 over x, and we have g over x is 3x minus 6. And it's asking us for when x is 3, okay? When f of g of x is 3. Sorry, I'm a little messy today. What you can do, you can put 3 into the g first. So the first step, you would say, what is g when x is 3? So 3 times 3 minus 6 would give 3. And then the second step, you would have f and put this 3 into it, put this answer in. And it should give the exact same thing. 1 over that 3, which is, well, it's just 1 over 3, which actually is the exact same answer we got before. And so there's 2 ways you can do this. You're able to actually make the full function itself if it asks for the general function. But if it asks you just to put a number in, you can do it in 2 steps. Some students just like to do it all together. Some students like to do it in 2 steps. It just depends on who you are, which one you choose. Okay, so I'll just put that to the side so you can at least use it for reference a little bit later when you look at my handwritten notes, if you look at my handwritten notes. Okay, is there anything I can go back over for that before we do a little bit more practice? Just keeping an eye on the chat.
Nothing.
Okay, Zuma. So let's move on. I was going to do this first one for you, but I'm going to have you try it. I want you to try the whole thing. Try all of question 1 and all of question 2, actually. So I'll give you, that should take you about maximum 5 minutes. I'm just going to see until I get maybe 3 or 4 answers in the chat, and then I'll move on. We have inverses to do today as well, which is a harder topic. But I want you to get practice with this first. So try numbers 1 and 2, and we'll regroup now in about maybe 3-4 minutes, okay? I'll be here if you want to ask a question. All right, so it's looking good so far, although Hisham, I think maybe there's something wrong with that 77. Okay, all right, yeah. So the answer is, it's looking good so far. A couple small issues. 75 for C doesn't look quite right, but we can take a look at that. I'm going to start writing out what I think these are, and we'll compare. Yeah. So it's f of g, so g inside of f. 3 squared. And so Sarah had written in the chat this answer, which is okay. I did say earlier, oh, n minus 4, sorry. It's okay if you kept it like that, although it's not really proper. It's not our standard form, our general form. So we normally like to expand that. So the first part here, that will be 3 times x squared minus 18x plus 81 minus 4. And then that should, when we expand that out, give this guy. I got to learn to write a little bit smaller, clearly. If I make any mistakes, of course, you got to let me know because I might not catch it. I'll write the second one. I'm seeing some more answers coming in. Your 3x squared minus 13 looks good. Let's check it with mine. So g with f inside of it. So in this case, I need to put f inside of where x is. Of course, g of x is x minus 9. We're replacing this x, yeah? So this x is now becoming a new function, f. Expand that. Now, notice it's not the whole bracket's expanded. This is the same thing as 3x squared minus 4 minus 9, which is why we get the minus 13. So, it's looking good so far. Now, the C and D are the easy parts. So I'm seeing 71 and negative 10. I'm seeing 71 from 2 people, negative 10 from just 1. You should be making sure that you can get these yourself, okay? So make sure if you're not writing it in the chat, at least you're trying it on your own. It's the only way you're gonna know if you can do this, okay? And I want you to be able to do this kind of stuff in the assignment, of course. So f of g of x, so we already have the function f of g of x. It's the first one. Just put x in for that. So 3, put a 4 in, square it, minus 54. I think I'm missing an x in the first one. Sorry about that. And put a 4 in there. And finally, I'm losing track. Sometimes there's so much on the page, I don't even know what I'm looking at anymore. And then if you simplify that, it should be 71. Let me know if I make a mistake. And then the last one, let's see. Tarek, your answer for 2 is all right, but you should have brackets with the 2x minus 7, just to be super clear. But yeah, you're okay. I think on your page, you probably wrote it correctly. G of f when f is 1. When I work this guy out, it's 3 and replace the x. Again, I'm looking to the top. Let me see here. 3x squared, so it's 1 squared minus 13. It's a little bit of a puzzle to make sure you don't lose track of what function we're talking about here. But once you've got that, I think you should be okay. So that's 3 minus 13, which is negative 10. So I'm just going to make it clear here. F of g of x is this, which is being asked for in this question, and so we used it. G of f of x is this, which is being asked for in this question, which is why we use that function. So hopefully that makes some sense to you. Let's see the answers that are coming in here. 1 over 2x minus 7 plus 5, exactly. So I'll keep that there. I'll just give the final answers here. This is 1 over 2x minus 7 plus 5. The second one you should get 2 over x plus 3. Let me see what's coming in here. So x plus 5, 2 over x plus 7 minus 7. Okay, so Tarek, when you did 2 over x plus 7 minus 7, make sure you simplify the 7 and the 10. So 10 minus 7 is 3. For C, it is indeed 16 over 3. And for D, it is 2. So Aisha, good job. You got that one. Rania, 16 over 3, perfect. Okay, so I'm happy that you're all trying this. The trickiest part is getting the original function, and then once you have those, just make sure you are careful when you put in your x values. And I think you'll be okay. Excellent work. I'm not going to show the full solutions right now because I think you have an idea what's going on here. If anyone wants me to, can you just tell me right now? Just let me know. I can write out the full solution. But otherwise, I'll put the full solutions online at some point. Are we okay?
That's fine.
Okay. I'll just assume that it's fine with everybody. You'll notice, I'm assuming you have the book in front of you. I have no way of knowing if you printed it or you use it on your phone or what, your computer. But hopefully you have this in front of you somewhere. This practice section is pretty long. And honestly, they're all done pretty much the same way. The only one I'm going to do for you is number 5. I want to do it quickly because I want to show you a case where maybe you don't want to expand it. So for example, Sarah earlier showed me an answer where you had a bracket and a square. And I asked to expand it. How do you know when to expand it and when not to? Well, normally it's if you're going to have a lot of fraction work. If you're going to be dealing with fractions and something weirdly complicated, probably best that you just leave it because it's usually not worth the hassle. So let me show you what I'm talking about. In 5a, f of g, so I'm going to put g in f. So that would be 3 divided by x squared minus 5 plus 7. The x squared minus 5 is our g, so I'll just make that in purple here. Actually, I don't really like that purple. I'm just going to change it to a blue for now. Sometimes I like to switch it up. So when we have that, that's easy to simplify. That's a 3 on top. X squared, the 5 and the 7 can kind of come together and make a positive 2. So we have x squared plus 2. So that's not why I chose to do this question. I chose to do this question because of part B. Part B is g of f of x, which means you put f inside of g. And once again, if you're not sure which one you put inside the other, notice that g is kind of like holding f inside. It's like hugging it, right? It's like, hey, I got you. It's okay. The world is crazy right now, but I got you, f of x. So it's holding it, so the f is within the g. It's composite. So what do we have? G is x squared minus 5. I'm going to put that whole fraction in. 3 over x plus 7. I'm going to square that, minus 5. I'm going to leave it like that. The reason for that is this course, of course, it's important to know how to simplify things, but it's kind of not worth doing that expansion because you'd get 9 squared on top, you'd get a big quadratic function on bottom, and then you'd have to match it with the 5 and do some fraction work, lowest common denominators and things like that. It's not worth it because we can easily put x values in this. So if you get a square with a fraction, if you get fractions squared, generally don't simplify. You can simplify, but let's not waste our time. I'm trying to give you a hand. You don't need why expand it. Okay, I might as well finish this question. In this question, we need to put in x equals 10. So I'll just give the final answer for C and D. If I put 10 into the first one, so f of g of x is this guy. I'm going to put 10 in here. That would give me 3 over 10 squared plus 2, which is 3 over 102. And that equals 1 over 34 if you simplify it. For the last one, f of g of x, sorry, g of f of x is this guy. I'm going to use it in this question. I need to put -2 in for when I see the x's. And now you can see the benefit to not simplifying it. I'm just going to say 3 over -2 plus 7 squared minus 5. I'm going to do the brackets first. Remember BEDMAS, brackets first, exponents next. That's 3 over 5. I'm going to square that and then take away 5. That gives me 9 on top, 25 on bottom. Remember, if it's exponents, you bring the exponent on top of that and the exponent on top of this one. 3 squared is 9. 5 squared is 25. And then I take away the 5. That's a little bit ugly. If you simplify that, or just put it in your calculator, you should get this. 1 fraction. All right, that'll be it for composite functions. Is there anything I can clarify?
Do I have to do all this? I can't do it with the calculator.
Which one? You mean
D.
the stuff? Yeah, just calculator. The reason I'm showing it is that for anyone who wants to do it more by hand, I want you to know exactly how. Because some students like to see the steps. You can, of course, calculate it if that's easier for you.
Okay.
So before we move on, anything else? Is the color distracting, like using the highlighter? I'm using it to help. If it's distracting, I can stop.
No, it's good.
No, it's okay.
Okay. Some people find it's a bit much, but I find if I was a student, that's how I would like to see it. So I just kind of like to model it. All right, let's move on then. That's composite functions in a nutshell. I don't know who just came in, but hello. The next thing we're going to cover is inverse of a function. And once again, I'll probably say this a lot. This has already been covered in Tom's videos, just like everything else. But I'll do my quick introduction and then we'll actually do the practice problems. What the inverse of a function means is, you'll remember early on, at the very beginning of this, we had our kind of function box or our machine. I showed that in class. It took things, it did something to a value. When you put numbers into it, it should give us a number out. So for example, let's just say this machine gives us a 10. The inverse is literally like the opposite machine, or the reverse machine, or the undo function, whatever way you want to call it. If this is our function, f of x, then the inverse is kind of like would be going backwards, whatever function that is. It would take 10 and give us back 2. So it's a way of saying, okay, well, I know what you did. Let's go backwards. So if it multiplied by 2 and added 10, it would take away 10 and divide by 2, if that makes sense. But we don't need to do that much thinking. There's a very easy math process, set of steps that we can take to find these answers. So let me do some examples right after I explain this. So the functions, I'm just going to read the box. The functions f and g are called inverse functions only if both the following statements are true. So the reason why it's starting this, it's saying, how do we know if a function is an inverse of another function? And what we know is if we put one function inside the other, instead of getting some random set of numbers back, so for example, instead of getting these more complicated functions back, it will give back the function x. It just pops an x out. So no matter how complicated it is, we put one function into the other, and it gives us back x. So let me summarize this. Functions are inverses if f of g of x is the same as f of x, g of f of x, and they're both equal to x. So you do both. You put one into the other and then do the opposite and see if they both give x. This example was done by Tom, but it's a good example, so I'm going to go ahead and write it out here again. So the question is, show that f and g are inverse functions. What that means, put one into the other. So the first step, I'm going to try f of g of x. We do the exact same thing as we did earlier. I'm going to take my f function, put g inside. So g is 2x plus 1, so I'll say 2x plus 1 minus 1 over 2. If I simplify the top, we can see that these cancel. That gives 2x on top and x on bottom. Sorry, 2 on bottom. The 2's cancel. And this is what I mean when I say it gives x. All right, that's a good thing. That means that it may very well be an inverse. We don't know for sure, though, unless we do it both ways. So I'll say 2. G with the f function inside. I'm going to take g, whatever f is, I'm going to replace all the x's with that. So g is 2x plus 1. So it's 2. And I see an x. I'm going to put f in now. 2x replaced plus 1. Let's see what that gives us. Well, right away, I can see there's a 2 here and a 2 here. They will cancel. That leaves us x minus 1 plus 1. And here we go. Cancel, cancel. They both give back x. That means they are inverse functions. They are, so let me write it clearly. F of g of x is equal to f g of f of x, and they're both equal to x. Therefore, f of x and g of x are inverse functions. I'm not going to write that out every time because that would be a lot of effort, but I want you to see it on the page, what I'm thinking, how I know that they're inverses, okay? They're inverse functions. Is that okay?
Yes.
Yes.
Okay, cool. Cool. One of these days you're going to go, nope, it's not okay. I need you to do it again. And I'll be waiting. I'll be there. Okay, so if that's clear, we can move on. There's different ways that we're going to work with inverses. What we're going to find, this is one way. We check and see if two functions are inverses by seeing if they give x. What we're going to do very soon is, given a function, tell me what the inverse is. So we're not checking two functions. We've got one function, and you've got to give me the inverse. And that's an easy process. If you watch the videos, you'll see it's an easy process. One thing that students tend to miss, so I'm going to try and make it clear here. I'm going to say this box is very, very important. I'm going to put 3 special stars next to it. Okay? Listen carefully. The range of x is always the domain of its inverse. So, excuse me, what?
Inverse. Inverse.
Inverse. Why are we saying inverse? Are you okay? It's nice to see you again, Ahmed. So the range, what this is trying to say is that if you have a function, its inverse switches the domain and range. All right? What I'm going to say here, inverse, I'm going to say is the change function. It changes x's to y's and y's to x's. If you have y's, it changes them into x's. If you have a range, it turns it into a domain. If you have a domain, it turns it into a range. And that is all inverses do. It literally takes everything and says, let's go backwards. That's what it does. So let me try to explain what that means by doing a quick example here. The question here says, I don't know who's leaving. I didn't think there's that many students to leave. Given that this is true, so let me write this in plain English. Given that when x is 2, y is 3, evaluate this, the inverse of the function when x is 3. Well, the answer is very simple. It gives back the number 2. The reason for that is it switches the values. Look, x used to give a 3. The inverse function, instead of taking a 2 and giving a 3, it'll take a 3 and give back a 2. That's the idea. So let me do another example. In this case, we want the function of the inverse. Let me show you. Inside the brackets here, let me make it clear. It's the function when we have the inverse of that 3? Well, we know that an x gave a 3, so we go backwards and we get back the 2. So it really is asking, what is f of 2? And we know what f of 2 is. It gives back 3. So this is kind of a weird brain puzzle. I hope you're following. It gives us 3. Let me make it more clear. The original function, when x is 2, gives a 3. The inverse function, when x is 3, gives a 2. So we can play with these ideas to figure out what I'm trying to figure out here, okay? And then, so having that in mind, can you try C? Can you tell me what C has to be here?
3.
3.
3.
Are you sure it doesn't just pop back a 2 or something crazy? Let's see. I'm going to do the inside first because that's how BEDMAS works. It's going to be get the inverse function of f of 2. We know that f of 2 is 3. All right, f of 2 is 3. And then we get the inverse of that. We need to throw back another number. Well, it goes from 3 to 2 is what would happen here. So the answer is actually 2. So these can be tricky. I know they're tiny little questions, but they can easily mess you up. And right then, everyone who I heard respond got it wrong because you said 3, right? Or did you say 2? I'll have to listen back to the recording. My memory is gone. In any case, it's a 2. Are we okay with that?
Yeah, I'm okay.
You're okay. Nafsa's okay. Abdullah's okay. I'm assuming Ahmed's okay. Both Ahmeds.
I'm okay.
We'll move on. Basically, it changes input and output. And this is just a little kind of puzzle question to try and make sure you understand that. Now, you should remember that when we did our functions earlier, we did something called the vertical line test, which you mean you cut your function down the center, and if it touches more than once, so if it touches twice, it's not a function. For inverses, because it switches domain and range, we do the horizontal line test. It's the same thing, but it checks for inverses. So I'll highlight the most important piece. You can determine if a function has an inverse by using the horizontal line test. Cut it horizontally, and if it touches twice, it does not have an inverse. So look, example, use the horizontal line test to determine if the functions below have inverses. Well, I'm going to take a line. I can pretty much draw a line through this anywhere. It's going to touch twice because it's a parabola. It touches twice. So I'll say clearly no. It does not have an inverse because it fails the horizontal line test. That shouldn't be difficult if you understood the vertical line test, okay? Abdullah, you want to sleep? You can go to sleep, man. I'm not keeping you up. You know, it's up to you what you do with your time. But I hope it's not me. Well, maybe it is my soothing voice putting you to sleep. Maybe that's the hardest part about math class is staying awake because I have such a soothing, relaxing way of explaining. Or maybe it's just boring. Either way.
Hi, Mr. No, it's not boring, but you know, I sleep in the first of the class, and now I wake up.
It's okay. I think all of our schedules are weird. I mean, I was answering messages from students at like 12:30 last night because I couldn't sleep. It's just weird. It's a weird time. So we're all in this together, as I keep saying. So anyway, this function doesn't have an inverse because it fails the HLT. I'm going to kind of have a little spoiler here for later. I get a little foreshadowing. Let's just say, let me bring up a different tool here. Let me just say I was to cancel the left side. Let's just like imagine that that part wasn't there. Like we restricted it. We cut it off and said, hey, let's ignore that. Then it would have an inverse. And that might seem like a silly thing to do, but that's sometimes what we have to do in order to find what the inverse is. So, okay, Nona.
Yes.
Sometimes we restrict the domain. so that we can make it get an inverse, okay? But that's something for later. So B, very simply, yes or no, does it have an inverse?
Yes.
Yes,
Yes.
because
Yes.
it doesn't matter where you put this line. I showed you this before, I'll do it again.
Yes.
You can use your hand, you can use a ruler, you can use your brain, whatever. All of these points, no matter where it touches the line, it only touches once, and that's a good thing, that's all we need. So it clearly does have an inverse. Yes, there's an inverse because it passes the horizontal line test. Easy peasy. Lemon squeezy. Japanesey. So let's do something a little bit trickier, which is having to restrict this function. And sorry, what was your question? Or did you have a question? I don't know if you're talking to me or not. So to find the inverse of a function, it has 3 steps here. It says check that it exists, which means do the horizontal line test. It also says that it may be possible to restrict the domain to make it have an inverse. That's a bit of a weird thing to think about. You might not know what I'm talking about yet, so I'll talk about it later. And then we need to replace x with f of x, which means switch x and y, and then solve for our new y. But the example obviously makes this more clear. Before we start, let me just show you, I've got these tips here, which you can look at later. This is how I like to follow the steps. First thing, think about the graph. Does it pass the horizontal line test or not? If it doesn't, then we're kind of wasting our time. So do that first. You can just sketch it. Second thing is to note the domain and range. Think about if there's any problems with it. Third thing is switch x with the function and resolve it for the function. And then in the end, your domain and range are switched. So I could talk about this all day. I'm not going to. I'm going to go right to an example, and then I'll come back to this if I need to. So let's do an example. Find the inverse for this function. Let me show you how this works. First of all, let me think about if this function has an inverse. Yesterday, you remember we learned how to sketch these? What kind of function is this?
Linear?
Yep, linear. And we have the a value is positive, yeah? The constant in front is positive. So it's linear, and it should look like this, uphill. So I can just draw a little sketch there. That clearly passes the HLT, or the horizontal line test, which means it does have an inverse. We just need to go find it now. Thankfully, getting the inverse is very simple. All we do is switch these 2 variables and then solve for the g of x. Tom does it slightly different, but it's the same. It really, really is the same. So when I see g of x, I'm going to call it x equals 4. And then you'll see here, I'm putting g of x there, but I'm not allowed just to call it g of x. It's actually the inverse I'm solving for. So I need to put this inverse symbol on top, which is -1. Have you seen that -1 anywhere else before?
1/4?
On sine.
On sine, yeah. So remember, sine of x is like 45, for example. If we solve for x, we use the inverse sign. It's the undo function, the reverse. So it's actually, that's the same symbol. It means inverse. It doesn't mean 1/. Sometimes there is a division involved, which Nonan, you just said that. It is actually going to be that. When we solve this, divide both sides by 4, we get our answer. The inverse function is x/4. I'm going to say 1/4x because that's how I like to write it. But they mean the same thing.
Yeah, that's what I said.
I'm sorry. I believe you. Yeah, 1/4x, x/4, same. Sorry, I didn't remember what you said. I have a lot going on in this crazy brain of mine. So let me show you what it looks like when we graph this. You know, right away, it's hard to know if this is an inverse. We could put one into the other and check it. If we wanted to, we should get x. But let me graph it and show you what it looks like when we have inverses, because to me, it's way more interesting. That might not mean anything to you, but it's interesting to me, so I'm going to do it because I'm the boss. So the original function, let's see, it was g. You should do this too. You know, what else are you going to do while I use Desmos besides try not to sleep? So g of x, our function is for x. So it looks like this, okay? Everyone can see that? It's this red line that goes up like this. What does the inverse mean? Well, I'm going to graph it. I'm just going to call it something else. I'll call it f of x. I just got to call it something. Actually, I'm not going to call it anything. I'm just going to put 1 over 4 x. And look at this. That might just look like some other random line, which honestly it is just some random line. But it has special properties. So for example, look over here. When x is 2 of the original function, when x was 2, it gave us back 8. So really this is the value 2, 8. That's the original function. The inverse function, instead of doing that, we should have the value 8, 2 on this. So when we put in 8, the inverse should give us back 2, and it does. So what we notice is it's like a kind of a reflection or some sort of like backwards version of the function. And this works for every value. If we had a 1 and 4, we'd get back a 4, 1, and so on, right? So this is the big idea. This is what inverses do. And one thing that you might have missed, I haven't talked about it, but Tom talked about it, is they're all reflected in the x-axis. So if we have this green line, you'll notice that it's kind of like symmetrical on both sides of that line. Anyway, that's what it looks like. I'll get back to that soon, so you can see what I'm talking about. I'll try another example. Tom did the B example. I would like you to try C, just to see if you got an idea here. Before you do that, I just want to sketch it. I can see that this is clearly a linear function, and it's shifted down a little bit, so it'll look like this. But if it's linear, it's going to pass the HLT, right? By that, I mean we can draw a horizontal line through it, and it's perfectly fine. So get me the inverse. Tell me what the inverse is. It should take you about not even 10 seconds. Was that 10 seconds? That was about 10 seconds. My steps, first of all, I check to see. Let me show you, so you have some idea of what I'm talking about here. Consider the graph and the HLT. It passes the test, we can move on. Note the domain and range. Well, the domain and range for this, it's a linear function. It goes on forever. It's safe. Switch x and the function to solve, and then domain and range will now be switched. So let's go ahead and do that. Hisham, I think you're right. I'm going to double check. Switch x and g. Again, switch these guys. Or ladies. Let's see, x, 2, and we're just going to solve for the inverse now. Some people don't like to write this whole function out because it looks ugly, but remember, it's just one big group. It's like a variable. And let's see what we can do with this. The 1 goes to the other side. It becomes x plus 1, and we have to divide it all by 2. So let me split this up. It becomes x plus 1 equals the inverse. You can get the answer directly. I'm just trying to make sure that everyone knows what I'm doing. Sometimes I give harder questions. And divide everything by 2. So that's our final function. Let me write it out clearly. The inverse function is x plus 1 all over 2, or 1 over 2x plus 1/2. But this is fine. That's our inverse function. I'm going to graph it. I'd like you, in the meantime, if you haven't tried it, to get this yourself. But, you know, get some practice graphing these. You can do this on a test or an assignment. It'll help you a lot to know if your answer is right or not. So I'm going to graph the first one, 2x minus 1. I don't really need to name them. 2x minus 1, it looks like that. Our other function is x plus 1 all over 2. So I'll put x plus 1, oops, sorry, all over 2, x plus 1 all over 2. And do you remember what I said about inverses? Hopefully you remember something about it. I said that they need to be like reflections through the line x, y equals x. So this red line is kind of like our midpoint or our middle, and the other one should be perfect reflections of it. And we can see that it is. For example, I'm not trying to over-explain this here, but let's see. Oops. Sorry, the Zoom annotation tools are kind of a pain in the butt. So just bear with me. The original function, the purple function, had a value, let's see, when x was 1.5, 1.5, we get a 2. In the inverse function, when x is 2, we get the value 1.5. So we can see that there's been a flip or a change or a switching of x and y, which is exactly and only what the inverse does. It gives us back the opposite of what we expect. So can I get a thumbs up, thumbs down, happy face, sad face, sleepy face, something or other to let me know if that makes some sense to you? That's a smiley face. That's good to see. Anyone else have anything interesting? I don't think Zoom supports stickers or GIFs or anything else like that, but can you show me you're alive some way or another?
Support, I think, thumbs up. Wait.
Hmm?
Support, how to put thumbs up like this
It
beside my
does.
name.
It supports that. I'm not sure what else. I think some basic like emojis, but I don't know if it
Yep.
will take anything else. I got a winky
Totally.
face. Oh man. I can go to sleep now. I don't even need to go do anything else. That made my day. Get a nice winky face. All right. My whole life has led to this moment. Okay. So the inverse, I don't even know what kind of face that is. I can't make it. It looks like anime. Okay. Inverse. I think I've explained it enough. X and Y switch in every sense. The only thing I haven't talked about really is domain and range. So sometimes we need to think about that. I'm going to skip 5. And I'm telling you right now, you have to watch the video for number 5 because Mr. Tom explained it. And he explained it fine. I think that it's important to catch it. So even if you just watch Mr. Tom's video on this topic and just watch this question, that would be important because it's an important topic. It's what happens when we restrict the domain. But I'll do another example similar to it, so at least you haven't missed anything too crazy. So let's see, I'm gonna look, I'm not gonna do all these, but I'm gonna look at a few. Let's see, I'd like you to, I already did one like A. I want you to try B and D. So they're already marked for you. Try B and D. Then I'll do E, and we'll move on to the last thing we need to cover today. When did this class start? I keep losing track of what time we have. I think it started at 2:10, yeah? So we have lots of time. So try B and D, please. Tell me what you get for your final answer. They don't take long. I'm going to write out my answer for A just so you have something to look at. So I just did A, just so you can have a few more worked examples without having to go searching for them online. Curious what we got for the next one. So 5S, not quite. I think we're missing something. Actually, yeah, 5 plus 1 over S.
About this.
I think this one is a version of it. S plus 5. Okay, so we're having a couple issues with rearranging here, I think, which is not a bad thing. I mean, that's why I give these. Getting a few different answers. S plus 5 over 1. I don't know about that. I'll give you another few seconds just to figure this one out because I'd like you to get it. My answer, I'll show you it, is this, or you could say this. So that would be my answer. Now, I could have made a mistake when I did this, but I'm going to work it out and see what I get. P squared plus P squared. Oh, you must be doing D. Okay. P squared minus 3 is what I got for the last one. But I'll check that after. Okay, I'm going to start working through B. Let's see, 1 plus 5S over H of S. Something weird going on there. So I don't know if what part got confusing here. So we'll see what happens. I'm going to start working through it. And if you notice something along the way that either I do wrong or maybe you did it wrong and you're like, okay, I see now. Hopefully you'll learn something out of this. So first of all, how are we going to solve this? The easiest way to do it is move, wait a second, let me just take a look and think about this. I'm trying to think of the fastest way. I'm going to multiply. Yeah, there's a few different ways to do it, which is why I can see there has probably been an issue here. I'm going to bring that whole thing to the other side. Or in other words, because it's a fraction, let me try to make this as clear as I can. Whenever you have fractions, you can get rid of the fraction on both sides if you multiply everything by it. So let me make this more clear. If you multiply everything by what's on bottom on both sides, now it's a little bit ugly, I get that, but sometimes this is what we need to do. It will cancel everything. Cancel, cancel, and we'll end up with that on the left side, and we'll have something easier to work with. So I need to rearrange here. So that gives us this ugly, ugly, ugly thing, which I'm going to give you a little tip on later. So we've got this. What are we going to do once we've got this? Well, we should probably expand. So multiply on both, multiply S by both of these, which I can think is probably what was going wrong with some of you. This is now S times that function, and then 5S equals 1. Now I can move the S to the other side and divide the S out, okay? I'm gonna need a little space to do this. I'm gonna move this one over here. I'm left with S, H negative 1 of S equals 1 plus 5S on that side, or 5S plus 1. And now, notice I'm trying to get here, yeah? This is my variable, one big ugly variable. I need to divide both sides by this S. So I'm going to cancel it there and divide on this side. And I'm actually done now. I'll write my final answer. So a version of this is perfectly fine. The reason I asked you to do that is because I wanted you to see if you could figure that out by yourself. Most of you could not, but that's okay. You've gotten the explanation now. So before I give you a slightly easier way to approach this, just to try to give you as many tools as you can in your toolkit, did I lose you anywhere there? Is there any of these steps you want me to go back through?
Silent.
I'm not sure what you said, but I think it was probably,
No, I said no one broke silent.
everyone's always silent. Oh, Ali has a question. So for the first one, why does the 2 divide with 3? In 1A, do you mean 1A? In 1A? Okay, so let me look at this from the beginning. Okay, I'm just going to steal this one. F of x is 2x plus 3. So to get the inverse, I need to go x equals 2. Okay, so this is what I was going to get to. So I'll kill 2 birds with 1 stone. Well, not kill it, but I'll complete 2 things in one fell swoop. I'm going to just call it y for now. And we can switch the terminology at the end. That's what Mr. Tom does, and sometimes it makes it cleaner while we're solving it. But first of all, to answer your question, we're trying to get to that value. We're trying to get to the inverse function, or trying to get to y. And in order to do that, move everything away from it first. It's kind of like opposite bed mass. You know, all the stuff outside, move it to the other side until we get to the y. So first step, we have x minus 3 equals 2y. In order to get to the y itself, we need to divide everything by 2, which is why I cancel this out. And so really my answer could be y equals x minus 3 over 2. And I can leave it there. Or you could also say y is 1 over 2x minus 3 over 2. And that would be the exact same answer. So your question was, why does the 2 divide with the 3? I don't know, did I answer your question? Because I'm not entirely sure what you meant exactly. Okay, wouldn't it be better to do all the questions by adding y? Yeah, so in hindsight, it's probably better to call it y first. And at the very end, you know, at the very end, instead of keeping these y values, change it back to the inverse. Because really, we're not looking for y, we're looking for the inverse function, but y is much easier to deal with. You know, you're looking at this big expression, or you can just call it y. And so maybe it's better to have just the y. I just didn't want to confuse you. I wanted to make sure you had the connection to the inverse without, you know, losing that idea. But yes, of course, you can use y if you want. And Mr. Tom, when he does his solutions, that's what he does as well. So it's up to you. You choose whichever one, but the final answer must have the inverse, okay? Because that's actually what we're solving for. Excellent. So let me shrink this down a little bit because I have the magic. If you guys don't have a tablet or something, you know, consider saving up some money and going to get one or something like that, because they're very helpful to have a pen to be able to do this stuff. I'm not a spokesman or anything for this stuff, but it's nice to have. So let's see. I said I was going to do C and D, but let's look ahead, make sure I have enough time. Yeah. C and D, let me see if there's anything special about C, or maybe I can skip it. Well, all right, I'm going to skip C, but I'm going to do D because I asked you to do D. And I'll do it my new way, where I'll just replace it with Y, okay? So I'll do the first step is to switch X and Y, or switch the X and the function itself. So I'm going to put X in place of the original function, keep my square root, but I'm going to call my function Y instead. Oh, I'm not solving for X, sorry, I guess it's a P in this question. So I'll keep the P there. But again, it's just a variable. Who cares what we call it? It makes no difference. Now, in order to get to the y, I have to square both sides because there's a square root. So I need to square it. I square this side, I square this side, and the squares, you should know that the square root cancels with a square. What I'm left with is p squared equals y plus 3, which now I need to move it to the other side. So yeah, I showed that's exactly right. Just going to move it over here and say, the 3 needs to go to the other side. So y is actually equal to p squared minus 3. The problem is, or at least, sorry, the thing you need to remember now is you must change this. If you want to use y, it is simpler. There's no question about that. But if you use it, you have to change to the inverse function at the very end, okay? So the final step, you must rewrite it as the inverse because, oops, the original question did not have a y in it. And so we're not actually allowed to just introduce a new y because that's just not how this works. We need to change the name, but as long as we do it at the end, we're okay. And now we can see that it's the inverse function where we can put a p inside of it and we can solve for whatever value we want. And that should be the inverse. Okay, so that would be my final answer. I see p squared minus 3. I seem to remember, Abdullah, you got p squared plus 3, but you changed the minus after, so I think we're all good on this. Long story short, let me go back and make sure you understand these steps now. So I'm just slowly scrolling up. Let me travel back in time to my tips here and talk about them one more time. First thing, consider the graph. I haven't been doing that lately. I should have been considering it. I'll draw some quick sketches when I go back down and note the domain and range if there's any problems. For part 3, we need to switch x with the function and solve. We've definitely been doing that. And then we say domain and range are now switched, which they are. So let me show you what I mean when I say you need to consider the domain and range, okay? So I need a little bit of space. I'm gonna erase this switch here. I'm gonna draw a quick sketch of what this square root function looks like. We did them yesterday. You should remember that the square root from what we did yesterday looks kind of like this. It's like a sideways curve type of thing. This clearly passes the horizontal line test. So we're allowed to get the inverse, and we clearly were able to get that inverse. What I want you to be able to do is tell me what's the domain and what's the range. That's a little trickier. The domain here, what's it going to be? Does anyone know? Does anyone have any idea? I guess it shouldn't be x, it should be p, and it should be, let me zoom in here. This is probably the trickiest part of this question. So let's look at this little sketch. Factorize it first. We don't really need to factorize. In fact, what I would recommend you do is graph it. You have the ability to put this into your supercomputer, which is your phone. This is literally a supercomputer. I don't know if you know that. And just get the function and then steal the domain and range from that. So the function is square root of p plus 3. So I'll use p, but it could be anything. Plus 3. So y equals p plus 3. Okay, or g equals whatever. What's my range for this? Sorry, what's my domain? What are all my possible x values? Well, if I look at this function, you can see that here, all of these x function exists. This is fine. But at some point down here, apparently it's, I think, -3. That is our smallest possible x value, or in this case, our smallest possible p value. We can't get any smaller. So we're limited. We say p must be greater than or equal to 0. Oops. greater than or equal to, sorry, I made a mistake, greater than or equal to -3. P is part of the real numbers. Sorry, I ran out of space here. And then my range, what is my range? I gave you a tip on this. I said, normally when we have these square root functions, the range is always the same. It's greater than or equal to 0, which we can see here. This is our smallest value. You know, this is our smallest possible y value. There are no y values down in this region. The function doesn't exist down there. So we say it has to be greater than or equal to. G is greater than or equal to 0. And it's part of the real numbers. So these are tricky questions. I'm not going to pretend that they're not. But I hope it starts to slowly make sense. And if you graph it on Desmos, I promise you it is much easier than doing it by hand. I showed you how to get this by hand yesterday. You solve for the root, make it greater than or equal to 0. But just do it on Desmos. It's easier. Now, the very last step. And I like this last step because it's so quick and easy. Let me just save some space. What's the domain and range of my final function? Well, it's literally just the domain and range flipped. So look, the domain, oops, the domain, sorry. The domain now is going to be the set of all p values so that p is greater than or equal to 0. I'll explain this in a second. And the range is going to be all of the g values so that g is greater than or equal to -3. And g is all the real numbers. Do you have any idea where I got these? Like, it might look like I'm just putting these out of nowhere. Just some crazy random guess.
Again, Mr.
So in the beginning here, my domain was this. The inverse changes that to range. Same thing. The original function had this as range. The inverse changes it to domain. This is a difficult question as soon as I try to talk about domain and range, okay? But just take your time, try to process it, graph it if you need to, which is what I'm gonna do now. I'll show you, you can get this, and you should be okay, all right? Let me show you. This is my function here. What if I had another function?
Mr. How we can draw by hand?
You can sketch it by hand, but we did the drawing and stuff yesterday, some simple sketches. You would normally use a table of values, like when x is 0, what's the y? When x is 1, what's the y? That kind of thing. So this is actually what we ended up making. We would need to restrict this. Actually, I'm gonna close it. I don't want to confuse anybody, so I'm gonna stop it for there. I'm gonna just show it by hand, because I don't want anyone getting too overwhelmed. Okay, so I'm going to do one more problem on this. I want to do the e, and I'm going to make it as easy as I can. Okay. First of all, this function, what does it look like? Well, this is e. You should know that it has a square. So from yesterday, we know that that's a quadratic. We also know that the number in front of it is positive. So it has a positive a. And what that looks like is it's actually going to look like this. And you could graph it on Desmos, so it would look the same thing. Does that pass the horizontal line test?
No.
No.
No, it does not. It fails it badly because it hits twice. So we need to restrict the domain. We need to force it to have an inverse. So what we do is we quite literally say, well, let's just ignore half the function. Let me try to get a good color here that I don't normally use. We just say, all right, well, let's It's supposed to be a pencil. Sorry, I'm getting fancy here. Let's just, let's pretend this part of the function isn't there. And we just consider half the function. Now that remaining part does pass the horizontal line test, and we can move forward. So the first step, we needed to restrict the domain. What is our x values? Well, I'll just keep it simple. Our x, our domain, greater than or equal to 0. I'm not going to write all the other stuff. You know that it's real numbers and so on. Let's just make it short. That's our domain. What's our range? Can anyone tell me what our range is going to be? I guess it's G.
From -8 to real number.
Yeah. It starts the smallest possible number. If you put x equals 0 in this, the smallest number is -8, because it's down here, and everything bigger than that. So we have our domain and range. X is greater than 0 or equal to 0, and the range is greater than or equal to -8. The inverse part is actually really simple now, okay? We're just going to do the switch. So I'll use the y like I did before. X equals y squared minus 8. Solve for that. Well, that's x plus 8 equals y. And I'm just going to move it over here. That means, oops, 1 second, I have a square still. I'm going to get the square root of that. Square root, that cancels with this. Of course, you should know that. And what am I left with? I'm left with y equals the positive square root of x plus 8. Not plus or minus, the positive square root, because that looks like this. Like the previous question, it looks like this sideways curve thing. You don't really need to know what it looks like. What am I missing here in my final answer? Does anyone know? If we're looking back at the previous question, what's something that I had to do? I'll just tell you.
Plus minus.
I need to, no, I don't write the plus minus because I'm not allowed. By cutting the function in half, I'm no longer allowed to say plus minus, I just have plus. What I'm getting at is I need to write it as the inverse.
G of x.
G inverse, the inverse function is actually equal to this. Okay, and if we graph that, we should see that they are perfectly inverses. It looks like this. The original function looked like this. And it'll be symmetric down the center, okay? Some crazy fish shape. Okay, and now the final answer here, the domain and range are really simple. The domain is just the old range. And the range is the old domain. Okay. So hopefully, it's a lot to take in if you're thinking about this domain and range, especially because yesterday was probably the first time some of you really thought about domain and range, and now I'm throwing it at you in a new place. But it's intersession. Unfortunately, we got to just keep on going, and you got to try to keep up. The train keeps rolling, as they say. So can I review anything on that? I have just one more very last thing I need to do before we end. Anybody? Take that as a no. So 2, I'll just write the answers. It's very fast. If 5 normally gives 1, what happens if we do the inverse? Well, this would give back 5. This would give a 5, which would then give a 1. And this would give a 1, which would then give back a 5. So that's the quickest way that I can do that answer. That's not a fraction, by the way. That's just me saying what the numbers come out to. And there's a very last check here graphically. It really doesn't take very long. Example 13 was already done. Practice 13 here, I'm going to quickly do. So it says, graph the function f of x and g of x and y of x on the axis below, and verify that they're inverses. Okay. I'm actually going to cheat a little bit and show you on Desmos, because I want you to get the idea. You know, I'm not going to be asking you to do too much graphing on the assignment or test, just because you're all at home. There's a whole bunch of reasons, but I want you to at least be able to get Desmos, and then anything about the graph you can understand. So once again, if you're not trying Desmos yourself, please try it. I don't know how many times I can repeat that. You can't escape it. I want you to try it, okay? So I'm gonna graph these three things. We'll know they're inverses if they are reflected about the x-axis. So square root of x plus 5 is my first one. X squared minus 10x plus 25 is my second one. I'm going to restrict the domain on that. You don't need to worry about that too much. Just trust me. Let me see here. 4 and 5. Okay. X squared root of 5. This function. I would give you a slightly easier one, an x. So this is the last thing I want to talk about. How do I know that these are inverses? Well, I know they're inverses because I can see a relationship here. Look, for this value, it's perfectly reflected about that line. It's still 5. For this value, or that's a pretty bad example, but pretty close, gives us this number. Actually, that's a bad example. If I have, for example, 25 in one of my functions, gives me back 10, or in this part here, that sorry, I'm trying not to confuse you. I think I might have. Let me just match. I'll show you that there's functions. The quickest way I can do this. This point here, for example, is 10, 25. This point here is 25 and 10. So they're perfectly opposites of each other. They're perfectly reflected about the x-axis here, okay? That's all I want you to show. If I wanted you to graph it on paper, I would give you probably the table of values and you'd put them in yourself and just tell me they're perfectly reflected about the x-axis, okay? That's all I'm kind of looking for. So I went 1 minute over time. I really don't try to do that, but inverses can be a tricky concept. All right, so hopefully that's okay with you. We'll pick up from there tomorrow and keep on keeping on. Hopefully things are going well with you. And if you have any questions, please just let me know, okay?